All right, so I'm going to kind of go back in the slides kind of quickly here. We're not going to take the quiz again, but going to the back. Yesterday we started and said we're going to start learning about wind, right? And one of the first things that we noticed about wind is we have to understand the difference between latitude and longitude. Now, longitude are those lines that go up and down, right? The lines that go up and down, you can kind of see them here. And this one important one is the prime meridian, because we start to read things in longitude as west of the prime meridian or east of the prime meridian. And there are very specific readings going west and east. And we understood that while longitude is important, it's not nearly as important as latitude, which are these lines, because where I am on these lines really depends on what type of climate I have. The closer I am to the equator, the warmer my climate. The further away I get from the equator, the cooler. And we labeled all of these different areas, right? We had the polars with frigid air, right? We had the temperate areas, which is where we live, by the way, in the mid-latitudes. And then we had the tropics with torrid, which was a word we used for where it was hot most of the year because of where you are in relation to the equator. And those things are very, very important because the sun heats up the earth differently in different places. It's going to cause some spots to be warm, some spots to be cold, and those differences are going to cause differences in air pressure, and those differences in air pressure are going to cause wind, among other things. Which brought us to this video and these questions. And then we talked about air temperature, and we took notes on air temperature yesterday. If you didn't, you can go back and watch the video. It's posted in the links. And we talked about how cold air sinks, and we can look here. Cold air, because it doesn't have as much heat energy, the molecules are closer together. And they keep getting closer and closer together until they eventually change in that physical change from a gas to a liquid. And when these molecules are getting closer and closer and closer, that means that air is more dense. So all year long, we've been saying hot air rises and cold air sinks. And now all of a sudden, we kind of have an understanding of why cold air sinks. Then we look at the hot air molecules, and they have more heat energy. They are further apart. And we understand that because they are further apart, they are less dense. And that is one of the reasons why hot air rises. And we're going to skip humidity for now. We're going to talk about this for just a few moments. So if we're looking at this, I need to understand a lot of things. Number one, I'm assuming that Ruby understands that the sun is heating up the earth, right? That it's the main source of energy for the water cycle and a catalyst for many, many other things. But I need to understand that it sends heat to the earth through radiation. We've already studied that, and so there's been a lot of time on that. When the sun is heating up the earth, there are a few things that are happening. When we have the land, and I will just draw like a quick thing of land here. There we go. There's the land. That's like an awfully humongous thing there. But as the land is being heated up all day long by the sun, we understand what's happening, right? The air above the land is starting to get more and more heat. So what happens? Well, we know that because hot air is less dense, the molecules are further and further apart, we have hot air that rises. Yes. If I ever take time to write it down, you probably need to take time to write it down too. Hot air rises. Now that's very, very important. Because as this hot air is rising, if I'm taking air out of a place, okay, and we did this yesterday with my balloon in a bottle. It was. I will in a minute.
My brother has asked me this several times. He says, why does the balloon always fizz out of existence? And I'm like, well, because it's You have to let all the air out sometime. You can't just keep your fingers on it forever.
Pause this so people are not watching the video. Sorry about that. Anyway, can't do that. The thing broke. But when we take air away from an area, it no longer has high pressure. When I take air away from an area, the pressure becomes low because air is leaving here, that leaves a low pressure. Now, this hot air doesn't just go up in the sky, the end. That's not how it works. Okay? Because it goes up into the air, we also know that somewhere, right, because we know it happens, cold air sinks. Correct? Hot air rises, cold air sinks. Why does cold air sink? Well, we just looked at the molecules. They're closer together. It's more dense. When the cold air sinks in this area, it causes a high pressure. Okay? It causes a high pressure. Now, here's something that's really important to understand, David. We said this yesterday. How does air move? How does air move? We did this with the experiment we did with the bottle. We wrote this down in our notes. How does air move?
From high pressure to low pressure.
So if it moves from high pressure to low pressure, why does it do that? Air moves from high to low pressure. And that's important to understand. But what we really need to understand is also what's going on up in the atmosphere. Up in the atmosphere. Kids, if all of this air is going up here, that puts more air, and I'm going to do it like, I wish I had like a lighter red, but I don't. Let's do it like this. When this air comes up, and this air, like this air over here is going up, and this air is going down, that leaves, again, another difference in pressure, right? If there's all this air up here, and this air is going down, then that means eventually that this air is going to have to come over here and replace this. And we have this, and you can kind of see it, this circle that goes around. That's a convection cell. Hot air goes up, cold air comes down, but it keeps going like that. And this is important that you understand this, Carter. If you can get this now when I do sea breezes and land breezes, it's going to be so easy. And also fun if you're at school. That's one of my most favorite things to teach at school. That's going to be really tough to teach online because we really have a good time with that one as we're doing that. Does that make sense about how hot air goes up, cold air comes down, it creates two different pressures, and that's one of the ways that wind forms. Make sense? Uneven heating of the Earth's surface is going to cause global winds. Okay, this might just be some winds in a local area, but we're also going to cause global winds as well. So I'm going to pause this at home, give my people in class a chance to write this down. You can pause the video at home if you want to. Sticking with this picture, I see some more vocabulary going on in this picture, and I'm going to write the vocabulary down in this picture. Over here, when I have hot air rising, there's a very specific word that we're going to use with that. This is an updraft. An updraft. An upward rush of heated air. An upward rush of heated air. Now that's pretty easy, right? You shouldn't get that mixed up. You better not say that an updraft goes down. That would be nonsense, right? It wouldn't be called an updraft at that point. We do have one that goes down. This is a downdraft. It's exactly what it sounds like.
Updrafts keep water droplets in the air.
It's a downward rush of cool air. You are correct. This updraft is one of the ways that the clouds are able to stay up into the sky. When we get to it, an updraft, strong enough updrafts are what causes hail to form, and very, very large hail to form. So we have updrafts and downdrafts. I have air moving horizontally, which is wind. Air moving horizontally, which is wind. If you look at this entire thing, and I'm going to try to do it in like this super light gray, but this constant circular motion that you see, this circular pattern of hot air rising and cold air sinking, is called a convection cell. This circular pattern that you see of hot air rising and cold air sinking is a convection cell. Boys and girls, when I look at this outline and this picture, I'm covering literally everything on your vocabulary sheet, because this is how updrafts, downdrafts work. This is how wind moves. We can see air pressure, because that's the downward force that's put on an area by the weight of the air above it. And this is eventually going to be what sea breezes and land breezes are and how they work. We just flip things around between the day and the night. The circular pattern just changes between the day and the night. That's it. This picture would be one of the first things I would draw my memory dump when I'm taking the test, because it gives me everything that I need to understand when we are moving into understanding like how wind moves, sea breeze, valley breezes, mountain breezes, land breezes, all of those things work in this exact same way. Does that make sense? Pause this.